This is video number 4 in the video series for Unit 3, Part 1, Lecture PowerPoint Notes. We're going to take a look at classifying elements based on their location. We're going to do a little deeper classification, and we are going to take a look at what we call valence electrons. So we already know that elements are classified by their group by having similar chemical behavior and properties. And the reason behind that is because of the number of valence electrons that we have in those atoms. Here we have the numbering system of 1 through 18. It's still the same periodic table. We just have a different numbering system here. And what we see in this orangey color, goldish color, are the alkali metals. In this yellow color here, we see the alkaline earth metals. And in this green, and also in our what are these? This is considered a metalloid. In group 17, these are called halogens. You'll notice that there's another name here where it says pnictogens and chicogens. We're not going to focus on those, but we are going to take a look at the halogens and the noble gases that are here. The thing to note about alkali and alkaline earth metals are that they're never found in their pure state. They're always going to be found in chemical formulas or as compounds, generally with atoms that are found on the right-hand side of the periodic table. They're both metals and they are reactive. Group 1 are more reactive than group 2, but they're both reactive metals. Group 7 are the halogens, and these are non-metals. They're corrosive, and they will generally be found in compounds with those elements that are found in group 1 and group 2. They're often found in salts made with metals, and they're also found in compounds made with other non-metals. Group 8 are the noble gases. They are noble, meaning they're snooty. They don't want to interact with other elements. They may interact with themselves, but no other elements. And they have very little chemical reactivity. And it's also because of the number of valence electrons that they have. And we'll look at that at the end of this video. So let's take a moment and practice. So pause the video, see if you can classify the elements that match the descriptions. And when you're ready to solve the answer, come back to see if you are correct. Are you ready? All right. So where are the halogens found? Halogens are found in group 7A or 17. So which of the elements in this grouping can we find in group 17? If you chose chlorine and bromine, you were correct. How about alkaline earth metals? They're found here in group 2A. Were you able to classify magnesium and beryllium as alkaline earth metals? If you did, great job. What about alkali metals? Alkalis are in group 1 or group 1A, and the elements that would be found in this grouping would be sodium and rubidium. Lastly, our noble gases are found in group 8A, or otherwise known as 18. And helium and xenon are found in the noble gas groups. The last thing we'll cover on this video is looking at valence number, or number of valence electrons. So if we take a look at the main group number using the A numbering system, notice that we've got 1A, 2A, all the way down to 8A. when we're taking a look at electron configuration and how electrons are grouped, we call the valence electrons those electrons that are found in the outermost energy level of an atom. The group number on the periodic table using the A grouping system tells us the number of valence electrons. And the atoms are grouped with other atoms that have the same number of valence electrons. So atoms in group 1A all have one valence electron. Atoms in group 2A all have two valence electrons. The noble gases are all contain, except for helium. Helium has two valence electrons. All of the other noble gases have 8 valence electrons. And because they have what we call a complete outer shell, they are what we call non-reactive. So elements in the same group number can undergo similar types of chemical reactions, all because they have the same number of valence electrons.